Hi students, today in this lecture we discussing the topic is general solution of non-homogeneous equation of higher order differential equation f of d into y is equal to q of x, where q of x is not equal 0. In the previous lecture we discussing to find out the general solution of the homogeneous equation, that is f of d into y is equal to 0. Okay, here f of d into y is equal to q of x. This is called non-homogeneous equation. So how to finding the general solution of this equation? First of all, what is the form of the general solution of this equation? See that first of all. So that is equal to here. We know that the general solution of the non-homogeneous equation f of d into y is equal to q of x is y is equal to yc plus yp, and yc is a homogeneous equation solution. Next, here q of x non-zero kada. The second solution is second part of the solution yp. So yp is called a particular integral. So in this lecture we are to discussing the special cases to finding the particular integral yp. Yc is the same only. The same procedure first to finding the yc, that is of choosing the auxiliary equation, finding the roots, finding the complementary function, that is the solution of the homogeneous. Next continuation, next to finding the particular integral yp. So where yp is equal to here, so yc is equal to here general solution of the homogeneous equation, and yp is equal to formula is 1 by f of d into q of x. ఇక చూడండి హోమోజినియస్ ఈక్వేషన్లో క్యూ ఆఫ్ ఎక్స్ జీరో కదా, అంటే క్యూ ఆఫ్ ఎక్స్ జీరో అయితే ఏమవుతుంది, వైపీ జీరో అయిపోతుంది ఆటోమేటికల్లీ. అంటే సొల్యూషన్ ఆఫ్ ది హోమోజినియస్ ఏమవుతుంది, ఓన్లీ వై ఈజ్ ఈక్వల్ టు వైసీ మాత్రమే ఉంటుందండి. ఎగ్జిస్ట్ ఓన్లీ వన్ సొల్యూషన్, వై ఈజ్ ఈక్వల్ టు వైసీ హోమోజినియస్. నాన్ హోమోజినియస్ ఈక్వల్లో both solutions yc and yp, we getting the both values, adding both yc plus yp, that is a complete general solution of the non-homogeneous equation. Okay na, this is a yp formula is 1 by f of d into q of x. But after finding this value, no arbitrary constant, because this is the particular value, particular integral ki there is no taking the constant andi. Okay na, మన general integration ki taking the constant kada, but this is a particular value, there is no constant. So now we will discussing methods, that is standard types to finding particular integral of f of d into y is equal to q of x. Okay na, so now here first method here, so general method to find particular integral. So given equation, non-homogeneous equation f of d into y is equal to q of x. So yp is equal to formula 1 by f of d into q of x. So now here 1 by f of d is expressed as partial fractions. So 1 by f of d converted to into partial fractions, and then using the formulas. So this is the one of the formulas are given only. So 1 by d minus alpha. D minus alpha is the one of the factor of the f of d into q of x is equal to given equation lo q of x. This is equal to formula e power alpha x into integration of e power minus alpha x into q of x dx. The second formula 1 by d plus alpha. This is another root. There is another factor of f of d into q of x is equal to here e power minus alpha x into integration of e power alpha x into q of x dx. Using these two formulas, we have to finding yp. Okay na. Yeah, first example here, solve d square minus 5d plus 6 into y is equal to e power 2x. This is a non-homogeneous equation, which of the form d square minus 5d plus 6 into y is equal to e power 2x, that is equal to f of d into y is equal to q of x. Where f of d is equal to polynomial of second degree, d square minus 5d plus 6, q of x is equal to e power 2x. Okay, first of all we have to finding the complementary function. So take the auxiliary equation, finding the roots. So that is equal to here f of m is equal to 0, that is m square minus 5m plus 6 is equal to 0. Finding the roots, m is equal to 2 comma 3. So m is equal to 2 comma 3 is a real and distinct roots. Therefore complementary function yc is equal to c1 into e power 2x plus c2 into e power 3x. This is a yc. And next to finding the second solution yp. So that is yp is equal to formula 1 by f of d into q of x here. So 1 by f of d is equal to d square minus 5d plus 6. Q of x is equal to e power x. E power 2x. Okay, now the general method is this is a 1 by f of d can be expressed as partial fractions here. First write the factors here. 1 by d minus 2 into d minus the 2 factors. So this is expression as partial fractions. That is equal to 1 by d minus 3 minus 1 by d minus 2 into e power 2x. This is a partial fraction. Now operating separately. E power 2x. That is equal to 1 by d minus 3 into e power 2x minus 1 by d minus 2 into e power 2x. So observing which form here? This is 1 by d minus alpha into q and this is 1 by d minus alpha into q. Using that formula only. So that is equal formula is e power alpha x into integration of e power minus alpha x into q of x dx here. Alpha is equal to 3, q of x is equal to e power 2x. So that is equal to e power 3x into integration of e power minus 3x into e power 2x dx. So similarly same here, alpha is equal to and q of x is equal to e power 2x. That is equal to e power 2x into integration of e power minus 2x into e power 2x into dx. That is equal to integration finding here. So e power 3x into, so this is integration of e power minus x here. So integration of e power minus x is minus into e power minus x minus e power 2x. E power minus 2x into e power 2x and e power 0 1 integration of 1 x. That is equal simplification is minus e power minus e power 2x minus x into e power 2x. E power 2x common. That is equal to general solution adding both yc and yp adding. So that is complete general solution is c1 into e power 2x plus c2 into e power 3x minus e power 2x minus x into e power 2x. So or another one is observing here c1 into e power 2x ఇక్కడ e power minus e power 2x both are same term చూడండి. e power 2x here అంటే e power 2x common c1 minus 1 అంటే c1 minus 1 is also same constant కదా, choosing another constant. So that is equal, this is also eliminating. So that is equal to getting the solution is c1 into e power 2x plus c2 into e power 3x minus x into e power 2x. అంటే yc ypలో there is no common terms, same terms. If getting the two terms same, so one term is eliminating, that is deleting in yp. So this is a solution of non-homogeneous equation, the general method when 1 by f of d can be expressed as partial fractions. Okay. That is delete the term minus e power 2x in yp because is same as in yc. See the second example here. Solve d square y by dx square plus y is equal to tan x. So write the operator form first. D square plus 1 into y is equal to tan x. That is f of d into y is equal to q of x. F of d is equal to d square plus 1. Q of x is equal to tan x. So find first complementary function. That is take the auxiliary equation is m square plus 1 is equal to 0. So roots are m is equal plus or minus I. So there is complex roots a plus or minus ib and a is equal to 0, b is equal to 1. So that is equal to complementary function is yc is equal to e power ax here. A is equal to 0, e power 0x into c1 cos bx and b is equal to 1. c1 cos x plus c2 sin x. That is equal to c1 cos x plus c2 sin x. This is a complementary function. Next to finding particular integral yp. Yp is equal to 1 by f of d into q of x. That is equal to 1 by f of d. F of d is equal to d square plus 1 into tan x. Q of x is equal to tan x. So 1 by d square plus, take the factors here. 1 by d plus I into d minus I. This is the factors and into tan x. Now by using partial fractions, that is equal, take the partial fractions here, 1 by d minus I minus 1 by d plus I. Take the LCM, we are getting the same only. So denominator there exists 2i kada, that is dividing by 2i. 2i cancel, we are getting the same term, the previous term. Okay, this is how converted to partial fractions. So now separating, operating, 1 by d minus I into tan x, next to 1 by d plus I into tan x. So let equation 2 here. So first finding 1 by d minus I into tan x find out here. Next one similarly you have to finding this one. Okay. So that is equal to here, first finding 1 by d minus I into tan x using this formula. Alpha is equal to here I. Q is equal to tan x. That is equal to formula e power ix integration of e power minus ix into tan x dx. So that is equal to e power ix into integration of, so e power minus ix can be write in the complex number which form, cos x minus I sin x into tan x dx. The e power ix is equal to cos x plus I sin x. So e power minus ix is cos x minus I sin x. That is equal to e power x integration of tan x is equal to, can be write sin x by cos x here. Tan x is equal to sin x by cos x. Here multiplying both, cos x into tan x is equal to, cos is a cancel, sin x minus sin x into sin x, sin square x by cos x into dx. So separate integration is e power x into integration of sin x into dx minus I into integration of sin square x, can be write 1 minus cos square x by x into dx. So e power x into integration of sin x dx here. Sin x dx is equal to integration of sin x minus cos x minus I into, because separating dividing, integration of 1 by cos x secant x dx. So integration of cos square by cos and cos x, integration of cos dx. That is equal to e power x into minus cos x minus I into integration of secant x log of secant x plus tan x. Here minus to minus plus integration of cos x sin x. So you are observing e power x into minus cos x plus I sin x here, minus common here, minus common, cos x minus I sin x minus I into log of secant x plus tan x. So e power x into cos x minus I sin x can be write e power minus ix again. Minus same I into log secant x plus tan x. So now multiplying with the e power x to both two terms. That is equal to e power x into e power minus x is equal minus 1. Minus I into e power x into log of secant x plus tan x. This is the first term. Next term finding 1 by d plus I gada. So in the above result, in the equation 3 we have to replacing I by minus I. Ikkada I place lo minus I replacing. That is equal to I by minus I replacing in the above result. We getting the directly 1 by d plus I into tan x is equal to minus 1 I place lo minus I plus I e power minus ix into log of secant x plus tan x. So now both substituting in equation 2. In the previous equation, from equation 2 both values substituting here, yp is equal 1 by 2i into the first values minus 1 in minus 1 minus I e power x into log of secant x plus tan x. Second value minus of gana into plus 1 minus I e power minus ix into log of secant x plus tan x. Now simplification is 1 is the cancel, this is the 1 cancel, remaining common 1 by 2i into minus I common, e power ix plus e power minus ix into log of secant x plus tan x is also common. So that is equal minus 1 by 2 I cancel. Here e power ix plus e power minus x is equal formula 2 cos x and. So e power x plus e power minus x is equal, adding both we getting 2 cos x into log of secant x plus tan x. 2 cancel. So that is equal minus cos x into log of secant x plus tan x. This is the yp end. So therefore the complete general solution is yc plus yp, both adding. Yc is equal c1 cos x plus c2 sin x minus cos x into log of secant x plus tan x. So this is the general solution of given non-homogeneous equation when 1 by f of d can be expressed as partial fractions. So similarly, third example. Okay, thank you. So this is the first method is over. For more videos, please do subscribe my channel, like and share it. Thank you.